I see none of our actual biologists that will be doing surveys. So
yeah, no worries. Yeah, we are recording so that folks can see it, because yeah, this was the time that with the doodle poll, most people that had like the most votes, but it's still not everybody could show up. So I want to make sure it's accessible to everybody. Cool. So I guess we can get started. So I have a PowerPoint that I was gonna share, and then for the eDNA section, we went out and took a video of actually doing the eDNA and talking through it. So I'll share that video when we get to that part of the presentation. And then at the end, hopefully, if I haven't answered all your questions, then we can just do like a question and answer, and people can ask questions. So first things first, I'm going to share my screen. Can everybody see this? See my screen?
Yep. Again.
Okay. Awesome. All right. So we will get started. So yeah, the objective of the study this year, we're trying to compare the efficiency and accuracy of 3 different non-invasive survey methods to estimate the occupancy and abundance of Harlequin ducks on creeks in Montana, Idaho, and Wyoming. This year we chose 10 creeks across Montana and 1 creek in Idaho that we are going to be essentially oversampling in order to try and learn at what interval can we actually sample to have a certain level of confidence that if we were to apply this method or methods to creeks that maybe we don't know if there are ducks on that creek, that we would have some level of confidence of detection. So my goals for today is just to talk through each of these methods to give folks an idea of what they can expect, explain what my expectations are from my end, explain sort of go through each of the data sheets and what the data is and what we're asking for, and then also just answer any questions so hopefully people feel good and confident. So like I said, we're surveying 10 creeks this year, or streams, and this is the list, and these are the survey dates that we're surveying. So we have Rock Creek in the Kootenai. In Idaho Panhandle is Marble Creek. In Glacier National Park, we have Upper McDonald, the Nyack and Waterton River. In the Flathead, we have the Spotted Bear and Trail Creek. In the Helena and Lewis and Clark Forest, we have the North Fork of the Teton and the South Fork of the Sun River. And in the Custer Gallatin, we have the Boulder River that we're surveying. So this is kind of what that looks like. This is in the protocol. There are maps of each of them, but if you're more of a spatial person and want to know where these creeks and streams are. So in the Kootenai, you can see Rock Creek is kind of between Troy and Thompson Falls. The Idaho Panhandle, we're south of this I-80 or I-90 corridor down there. In the Custer Gallatin, we're over like east of Livingston. In the Flathead National Forest, there's one up in the North Fork, and then the Spotted Bear River down in the Bob Marshall. And then in the Helena, Lewis, and Clark, these are both on the Rocky Mountain front near Choteau. And then in Glacier, Waterton River's up near Canada, and then Upper McDonald Creek and the Nyack Creek. These are our creeks that we selected for this year. And we selected these rivers and creeks and streams by just discussing with folks who do Harlequin surveys fairly regularly, and we decided on creeks that have we have found ducks on in the past more regularly than some of the other creeks, and chose sections that we thought were going to be the most successful. So I wanted to go over kind of what our survey schedule is going to look like. So each of these surveys are 3 days back to back. And on these surveys, we're surveying each creek twice, right, for 3 days back to back. And the first day is a ground-based survey, and we're asking that people record a stream flow measurement just at the beginning, to try and get at some just like stream characteristics to try and just be able to classify what kind of streams we're looking at. And the first day is going to be a really important day because you're just doing a ground-based survey. That's all you're doing, but we're just asking that you just really pay attention to where you are, like learn about the stream, notice any important features that you have, notice where you see ducks, notice sections that maybe you can't be in the stream or are harder to survey, and just like really taking note because you're going to be in the stream for 2 more days and then in 3 weeks visiting that same stream again. So we're spending a lot of time. So just like really that first day, just like really take note of what you notice, and especially where the ducks are, because on day two is our eDNA day, and day 2 is probably going to be the longest day in terms of just like time on your feet outside. So each day we're asking that folks do a ground-based survey, but days 2 and 3, you're doing a ground-based survey while also doing either eDNA and setting cameras. So you'll do a great ground-based survey. Again, just take stream flow, and we're just asking for you to take a stream flow measurement just right at the beginning of the day, and then you don't have to carry that gear with you. Just once at the beginning is fine. And so then for eDNA, we are going to take an eDNA measurement every quarter mile or 400 meters for the entire length of that stream. And so each stream section is between 2 to 5 miles. And so you will have enough eDNA kits and a couple extras to cover that section of stream. And then for 1/4 of the stream, we're going to do an intensive surveying. So that's measuring eDNA every 100 meters. And the reason why we're doing that is because there's a lot of variables with eDNA that we're trying to learn about. And so we're trying to learn, like, can we detect a duck farther down a stream, or do you have to be within 100 meters of a duck to detect them with eDNA? Or can we detect it, a mile down the stream, in which case you don't have to like see ducks to take it, and it could be a really, really useful method in the future. And then with eDNA, each time you take an eDNA sample, we're asking to take a turbidity sample, which is just like how clear is the water column, and that can be done simultaneously while taking the eDNA filter or eDNA sample, especially as there will always be multiple people, so one person could take turbidity while one person takes eDNA, and the turbidity will only take a couple seconds, and so I'm going to go over what that looks like. And then day 3 of our survey is, again, ground-based survey. Take stream flow at the beginning, and then our game camera day. So on the first survey done, the 3rd day is when we'll have folks place cameras on the stream, and then on the 2nd survey, day 3, is when folks will take down the cameras from the stream. And so just to explain sort of why we're going to each stream 2 times, it's because harlequins are a boom or bust species. And so we're worried that if this year happens to be a bust year where there's not that many chicks, if we only visit the creek 1 time, but we go later when we might expect to see chicks, we might not detect any ducks at all because they maybe had a bad clutch year and then would have left by then. So we're trying to hit each creek twice, once earlier even if it's a bad year for clutches, that we would detect single females before they migrate back to their molting and wintering grounds. And then again, if hopefully it is a successful clutch year, that we would be able to detect them with females. And so we're surveying twice to just try and really be sure that we will catch ducks at least at one part of these survey periods. Cool. So now I just want to talk through kind of the protocol for each of these surveys. The ground-based surveys are logistically the easiest, and I think a lot of folks have experience doing these surveys, and so this should be pretty straightforward. But we'll be working in teams of at least 2 people, and it's important that at least 2 people are the same all 3 days of each survey, because having different observers is important, because some people might be better at detecting ducks than other folks. And so if we're having different observers each day, that's just an extra variable that we're not accounting for. And so it's important that at least 2 of the people are the same observers all 3 days. And it can be a different 2 observers on the second survey when we come back 3 weeks later, but for those 3 days back to back to back, it needs to be the same 2 people. So we'll work in teams of at least 2 people. I think all the creeks and streams have at least 3 people signed up so far. Some of them have 4, and so we have plenty of people, which is great and awesome, but there'll always be at least 2, and the goal is to walk upstream in the stream and look for ducks and other water related species. When you get to a part, there might be parts in the rivers and the creeks and streams that you cannot walk in the stream, and when that occurs, we'll do what's called the leapfrogging method, which is more or less what it sounds like. So one person will stay on the shore and keep eyes on the creek, scanning typically downstream to upstream, because the harlequins tend to forage downstream for about a mile until they fly upstream. So if you're really just scanning under brush, under rocks, logs, looking at rocks that they could be sitting on in pools, backwaters, and then slowly moving your way upstream. And then the other person or people will move around that person to either a predetermined geographic location or a time. And so that could look like for me, when I do this on a creek that I don't know super well, a lot of times I like to do short jumps where I'll just say, give me 3 minutes, and just make sure that however far I get in 2.5 minutes, I'm making my way back to the creek so that I'm on the creek in 3 minutes. Or it could be I can see up to that corner, go up to that corner, and I'll see you when you pop out. And then once the other observer is in place, the person who was waiting back behind will move forward, reconvene with the person ahead, and then agree on the next spot that they'll jump ahead, and so on and so forth, until it is safe that you can walk in the water again. And then sometimes you might have to do one big leapfrog around if, for example, you're disturbing, you see a duck, or even this happens with other species like dippers. You could just be pushing them, and they're just continuing to go upstream because you're walking right behind them. And so just being aware of your disturbance. If you're pushing a duck, maybe just do a leapfrog around them so that you stop pushing them and they can do their thing. So that's the ground base. And then so the stream flow, like I said, we just are asking that it just be measured at the beginning of each day. And so the procedure is pretty straightforward. I actually have a quick 1.5 minute video that explains this that I wanted to share. It's super quick, but I think just does a better job than I can do. So I'm going to share this with y'all. Can everyone see the video?
It's loading up, Holly.
Okay. All right, let me know if you can't hear it as well. It should be able to.
Measuring the flow of a stream is important to understanding how much water is at a certain point at a certain time. Flow can be calculated using the float method with a measuring tape, small plastic bottle, and a timer. Flow is best measured in a run where water is flowing, and when there are 2 observers. First, determine the float distance by measuring and marking 2 points along the length of the channel. Try and get at least 10 feet. This length will be your distance. Next, measure 3 depths across at the channel cross section. Average those 3 depths, and this is your depth. Next, measure a representative width of the stream, and that will be your width. Now let's float the bottle. Partially fill the float bottle with water. 1 observer stands at the top of the reach, and the second observer stands at the bottom. The observer at the top tosses the float bottle into the channel and calls out "start" when it crosses the upstream point. The other observer will start the timer. And as soon as it crosses the second point, they'll stop the timer. Repeat this toss process 3 times and average the 3 times together. Use this average as your time entry. Now you can determine the flow in cubic feet per second by multiplying the width and average depth by the product of the distance and the time. A correction factor is commonly used because surface flow is faster than flow in the water column.
Cool. So that is more or less how we're going to take stream flow. It's pretty easy. It should only take folks a few minutes at the beginning of each day, and we would appreciate that. So yeah, so this is what our survey form for the Harlequin or for the ground-based surveys look like. And so I just wanted to talk through a few of these things. So if people are not super familiar with like what etho means, for example, feel more confident. So the first thing to record at the top is the date, observers, when you start the survey, when you end it, and then the creek you're on. And then right below that in the flow rate, this is where we have like the distance across the creek. We're gonna ask if you could just measure the distance every that says foot. It should be every meter across the creek. So I will fix that. And then to float the rubber duck down the creek 3 times and just record the time that it takes. So then once you start the survey, so you say you see a species, record the time you see it, and then record what kind of species with their 4-letter codes. So Harlequins are HADU, HADU, the number of birds you see, and then the group type. So is it like a single female? Is it a brood? We probably won't see pairs when we're doing it. And then where you see it, latitude, longitude. The geographic location would be just sort of like an indicator of where you were. So if we were to put in the UTM or where the bird is, the UTMs where you are, we could get a night and look at it at like on Google Map or something. We could look at it and you say, let's, on the corner just upstream from this UTM. That's helpful, or on a big boulder or at the base of a cliff. The stream location is like what is the stream right in front of where you are. So these options are pool, which is just a deep, slow moving water, a rapid, fast moving water that has breaking waves. A run is a fast moving water that has no waves. A riffle is just shallow and turbulent. A cascade is stair-stepping. A confluence is where 2 or more streams will merge. Or a laminar, which is just like extremely slow, glassy flow. Eddy, where the water is swirling and maybe moving backwards. Or if the birds are along the shoreline, that's edge. How far away from you is the bird? Awareness, do they know that you are there? And are they aware of you? And so the etho is what is their behavior. And up in the top, you'll see the etho options. So foraging, preening, resting, defense, alert, disturbance, courtship, social interactions, swimming, or flying. You can just put one of those two letter combo, and then number of people on the shore, excluding yourself. So that could be like if you're, for example, like on Upper McDonald Creek or on a creek that has like a trail right by and there's other people making noise and walking, and then comments. And one thing that we are interested in as well is if when you first notice or see the duck and it doesn't notice you, and you record its behavior, but then say like 20 seconds later, it does notice you and it goes from, foraging to all of a sudden like alert and being disturbed. If you could record that in the comments, we think that's really important, especially with like hens with their chicks and just getting some idea of like disturbance, since we are, trying to learn about non-invasive methods and not disturb them. So then for environmental DNA, I have a video that we made, so I'll share that. But the gist of eDNA, what we're asking is that folks collect eDNA every quarter mile or about 400 meters of the survey route. And then for 1/4 of the total stream length, which will vary from stream to stream, you'll record eDNA every 100 meters. And that 1/4 is you're going to get to decide from what you learned from the day before, from the first day of the survey, like where did you see ducks? And you can decide like, okay, this is the quarter that we're going to intensely survey. So I am going to share the video that we made. All right, can everyone see this video?
Yes.
I can see it, Holly.
Awesome.
Yep.
Okay. Here we go.
Hi everybody. So I want to show you how to do an eDNA sample. We're going to talk through everything. So first, this is all the equipment that you will need when taking a sample. So we've got our pump. We've got the power cord that connects our pump to our battery. Make sure that you charge the battery before you go out so it is fully charged. You will have a tube. This tube is what the water will be filtered through from the creek or stream or river through the pump into a bucket. We will be taking 5 liters of water for every sample. So this bucket has liters marked. There's 5 liters in it. It is also acceptable if you are somewhere and carrying a bucket is not going to work for you to bring like a Nalgene and just make sure that you count 5 times as you empty it out. We also have our Sechi discs that we have made for everybody to get a measurement of stream turbidity, and an extension pole. It's a paint pole that extends that we put a clamp onto, and this will be for taking the eDNA sample so that you're not standing right behind it, stirring up sediment or stirring up anything into the filter. And so we will talk about that as well. And then the other couple things that you'll have is your filter sample. So this is our sample kit. And in this kit, you do not want to open this kit until you are ready to take your sample, because everything in here is clean, DNA free, and as soon as you open it is when things start to get contaminated. So don't open it until you are ready to take your sample. Inside this kit, you have, let me show you, you will have your filter cup. That is this. Has the filter inside and what the water will be running through. You have clean gloves. You have clean set of forceps, and you have a bag of silica beads for storing the filter after. Cool. Okay. And then the last thing that you should have is your data sheet and a marker and a pencil. And yes, we will go over all of this. So, first things first, let's set up the eDNA pump. The first thing you do is you want to be somewhere that is flat or that the eDNA kit is sturdy. It's not going to fall into the water. It's not going to fall off a rock and get busted up. So we'll place that. Then you want to connect the pump, or the pump to the battery with our cable here. So we have this end that plugs into the pump, and then with the battery, the positive and the negative sides, kind of like if you're jumping a car. So you put positive on the positive, red on positive, black on negative. And then you want to set up the pump. So this is one cable, and the way you set this up is this end, there's two ends I guess I should show. So this end, this is where your filter cup is going to connect to this end. This end is where the water is going to come out into your bucket when you're measuring 5 liters. So you want the end with the filter cup to be longer because this is the part that's going to be stretched out into the creek to collect the water. So, but you want to leave enough space as well when you're putting it through the filter that it can go into the bucket without like spilling water all over and getting everything wet. The way that you set this up is this tube goes through the pump right here. So you'll open the pump up and then you run the tube through it like so. See that? Cool. And then once you're set, close it back down. And to make sure that you put the pump the correct direction, you can turn the pump on. Oh. Once again. Make sure the pump turns on. This is why you charge your battery. There we go. There's the pump. Okay. So to make sure that the pump is, or that the tubing is going through the pump the right direction, you'll turn it on and you can feel the filter cup and you'll feel a suction. So it should suction, and then this side, the opposite side, should be blowing air out. And that's how you know it's the right direction. If you put the tube in and this is not suctioning to you, then you have the tube the wrong way. Turn it off, take it out, flip the tube around, and try it again. Alright. So, now, I believe that we are ready to begin. So that's how you set up the pump. Okay, so now we are going to open the kit. So now once you open the kit, whoever is taking the eDNA, you are now not allowed to touch things. So you don't touch your face, don't touch your hair, don't touch things that might have extra DNA. You want to try and be as clean as possible. Okay, so we're opening it. First thing we'll do, we'll put on our clean gloves. Okay, next we're going to take out the forceps and the silica, and we're going to place them somewhere that is away from things with a lot of DNA, such as the pump and the bucket and the filter, but open them just slightly so that they're easy to access, and set them away from things, so your backpack as well. Make sure they won't get rolled on top of or blown away. You want them to be easily accessible but away from potentially highly contaminated objects. open this, but it's not too open, so like dirt and stuff's not blowing into it, but it's open enough for easy access. Okay, next, oh, sorry, I have my glove on backwards.
Elizabeth.
So next, you take the filter out of the pump, or out of your bag. Now we are done with this bag. Let's see if this doesn't blow away. And you're going to hold, we're going to attach the filter now to the tubing to the pump. And so the way you want to hold this filter is you're going to hold it in a way that the bag acts as like a second glove to it. So I'm holding it with my glove. And one thing to think about is you're going to have like a dirty hand and a clean hand. So make sure your clean hand is like your more dominant hand, because your dirty hand is going to be touching the tube, touching the hole into the water. So bring this down. So the end is exposed. So this is where we're going to attach this pump to, and then the filter is on the other side. And to attach the pump, you just slide it on and push it on like so. Once you have the tube attached here, what we're doing for our project, because we are in potentially faster moving stream and we don't want to knock up, or slow moving stream, and we don't want to knock up gravel, silt, things on the ground to get in the way, we're going to use our extendable paint holes. So again, holding this with the clean hand, dirty hand. And we're going to put this sample into the clamp, but we're clamping it in the hole so that it's not pinching the water. So the water can still get through nicely, but it's nice and sturdy. It's not going to go anywhere. So then, once that's ready, you can take this off. That back. Now we're ready to take some water samples. Okay, so now what we do is we're going to put this in the water and turn on the filter. And you'll see that water is starting to pump through into the bucket.
I had to cut this video into two, so I have to open the second part real quick. Okay. Here's the second part of the video.
Water is starting to pump through into the bucket. So now we'll hold this until we get 5 liters of water. Probably turn it off now, and then we'll just reset. Okay, so now we've been filtering for about 5 to 8 minutes, and we are at 5 liters. So what you're gonna do, as you can see in the bucket, we're full. You're gonna take the pump out and hold it up, and then allow the pump to run for another about 30 seconds to a minute, because we're trying to dry the filter. We want the filter to be completely dry. So like this, and I'd zoom in on that, see the filter drying. Give it a second. Probably this hardest part. Okay, so now, has it been about 30 seconds? Okay, so now that it's been 30 seconds or more, we can turn off the pump. And now what we're going to do is we're going to be removing the filter. So we can take it out of our paint clip now. We're done with this. Set that to the side. And you will take this cup, and this cup just pops just pops off like that. And once you pop the cup off, you're also done with this. So you can set that to the side as well. Then the next step is using your clean hand, you're going to get the forceps that you set to the side earlier and take them out, trying not to touch the tip because there could be some contamination on your finger. Yep. Then using the forceps, what you do is you take the filter that has now filtered all of the DNA, and we're going to fold it into fourths. So we'll grab it. Maybe, there we go. And fold it into fourths. So fold it in half once, and then fold it in half a second time, like so. Then, this is our sample. This is what we're trying to keep. We will take our bag of silica that you open slightly and set to the side. Drop the sample into the silica. You're now done with the forceps. Set those to the side. Close the bag. Push out the air. And zip up the bag. And then, just make sure that your sample gets kind of like inside the silica beads to keep it dry. And then what you're going to do is you're going to label this bag. So what you're going to label it on, that's where the Sharpie comes into play. So we did practice one earlier, which I'm going to point out one of our mistakes that we made earlier, but more or less what you're going to sample on is the creek. So we are on Upper McDonald Creek, our site. So this will be like what number sample you're on, 1, 2, 3, 4, 5, 6, and so on. Or no, our site is Upper McDonald. I wrote site training because this is for a training video, so we knew that this wasn't part of our videos. Then the sample number is the sample 1, 2, 3, 4, 5, 6, and so on. The date, how many liters of water were sampled, so we filtered 5 liters of water. Your coordinates, and then the initial of the sampler. You will record all of this with the Sharpie on this piece of paper. And then there are, also at this point, you can take your gloves off. We're done with our gloves. And set those to the side. Cool. So then the next step is every bag will come with an envelope, and you'll fill out the same information but on the envelope, and we'll store the envelope, or we'll store the sample in the envelope, and this is what we'll send to the genomics lab. The envelopes, if you don't want to carry these with you the whole day, you can fill these out later when you get back to camp or get back at the end of the day. But make sure you fill them out with all the exact same information. And if you're not going to bring one of these with you, or with your envelopes with you, make sure you know everything that you need to put on the bag. So the one thing that I change color to purple to.
Sorry, I'm gonna fast forward just a second because I said something that's not true at this part of this story, so. Oh no. Oh, 1 second.
Well, I'm seeing my face, but other people seeing their faces when they're looking at it.
Read is on Zoom.
Okay. Can people
That you,
get,
they can probably see it.
here is the rest of the video. Sorry about that.
She did a good job.
Yeah.
Ollie, I can't hear the video at this point.
Oh, okay, hold on. Let me make sure I'm sharing my sound. Thank you for letting me know. Okay, let me know if you can still not hear it.
The eDNA sample, another person or person in the group can be taking a turbidity measurement, and so that's what this is for. This is a Secchi disc, and the Secchi disc is used for measuring stream clarity. I think that most of the streams that we'll be surveying are going to be pretty clear, like Upper McDonald Creek here, but if they're not, this will be a good measurement to help us learn. Maybe we can't take eDNA in certain level of turbid streams. So the way you measure this is pretty easy. We will have a measuring stick and this disc. We forgot our measuring stick for this video, so I'm going to use this paint pole as just an example. So pretend that this has markings and is the distance. But what you will do this behind, downstream of whoever is doing the eDNA, because you don't want to contaminate the samples in any way or wait until the eDNA sample has been taken. But you will lower the disc into the water. You can use the paint pole to help push it down. And you're looking down into the water, and if you can see this disc clearly all the way at the bottom of the stream, then you'll record the depth of the water, so whatever this measures to, and the and you'll say you can see it clearly. But if you cannot see it clearly, what you're going to do is you're going to slowly lift it up until you can clearly see it, and at that depth you'll record the depth that you can clearly see the stream, or see the Secchi disc. We got these discs made from the sign shop, and so they should sync for you. It's a little tricky for us right now because we're at extremely high water, and so it's kind of just being pushed. But I think using the paint pole and your measuring stick, it should be pretty straightforward in getting it down and getting a measurement. But that's what this is for, and how we're measuring turbidity. And so then you should have your survey form, and this is the information that we're interested in. So
cool. Cool. So I'm gonna talk about the survey form, but I have it in the PowerPoint, so it might be easier just for folks to see it here. But that is more or less how you take eDNA. I hope that video is helpful for folks. I can make it accessible if people want to watch it again. So turbidity, we just talked through that as well, but here's the survey form.
Hey, Holly.
Yeah.
I do have a couple of questions.
Yeah.
So when you're testing that tubing, like suction stuff, do you need to be careful to not touch it with your hand? Like, how does eDNA transfer, like, with that tubing work out?
Yeah, so the filter is going to be on the other side, like on the other side of the filter. So like where I was touching it with my hand, that is like water that's just going to go into the bucket. It's not going to touch the filter. It's on like the other side of the filter. So it should be okay to touch that part of the tubing and not contaminate your sample.
Okay. And that's why we can keep reusing the same tubing at every site upstream, because it's
exactly, yeah.
The tubing doesn't have to do with the DNA. It's just that filter.
Exactly, just like that
Okay.
cup. Yeah.
Good. Thanks.
Cool. Yeah, no problem. But yeah, so this is what the eDNA survey form looks like. Again, at the top, the date, observers, the creek, and then the site number. So this would be like, well, Survey Creek is Upper McDonald. Site number would be like what sample you're on, 1, 2, 3, 4, where you are. who is taking the survey, how much water is filtered. And the reason we're asking for this is so ideally we would get 5 liters of water for each one, but sometimes what we've been told is stuff happens, filters clog, and you can only like filter maybe a couple of liters. And so if that is the case where all of a sudden there's like no water is filtering whatsoever, just record that. And so we know if you weren't able to filter all 5 liters. And then what time it is, were there ducks visible when you took this sample? So this is really important. And then the distance from ducks, because this is what's going to help us know, like, okay, we detected them 100 meters away or 200 meters away, and so on and so forth. The stream location, this is like the same as the ground-based survey, so like pool, rapid, run, riffle, and go and so on. And then for the turbidity, so just when you put the Secchi disc all the way to the bottom, can you see it clearly? Yes or no? And then if yes, what's the depth of the creek where you're standing? And if no, what is the depth where you can see the Secchi disc when you start to bring it up? And then any comments you might have in the notes section. So that
Hey,
is
Holly?
what this, yeah.
Oh, sorry. I was just going to ask real quick. Do we want to make a note if the duck is below us or is upstream or downstream?
Yes, that would be a great thing to put in the notes.
Okay. And another thing on the Secchi disc, if you could put markers on the string itself, you know, like every 10 centimeters or every meter or something, that might be a helpful way to measure it as well.
Yeah, totally. That's a good idea. Thank you. I'm gonna write that down. Okay. Sweet. Cool. Any other questions for the eDNA and turbidity before I move on?
One clarification. So we are just doing this from the stream edge because we need to have the pump on safe dry land. Like we wouldn't want to do it out in the middle, or how's that work?
Yeah, correct. So the pump, the pump, you want it to be like sitting somewhere that it's not gonna like fall into the water or get destroyed. So that is part of the goal of using that paint pole, is to try and stretch it as far out as possible. But some creeks that are smaller, you might be able to get more in the middle, but unfortunately on like the much wider creeks, that's probably about as far as we can go out, just because the eDNA kit, we don't want it to, or the pump and battery, we just don't want that to get drenched and wet.
Holly, I was going to ask what the plan is for when you have a braided stream and you've got multiple channels, what your sampling looks like in those situations. And then one other scenario that's coming to mind for me is Rock Creek and the cabinets will be, it'll go underground for a portion of the stream, or it might go partially underground. Do you want to sample if there is water, if there is surface water, but not floatable by ducks, or you know, what are the thoughts there?
Yeah, those are great questions that I haven't really thought about yet, because most of the creeks that I have been thinking about were the ones that I knew that aren't as braided. And so I think I would like to think about that a little bit more before I answer, if that's all right. And I'll get back to you about those questions.
Can I jump in here, guys? This is Lisa.
Yeah.
Hey, Bryce, I've only seen Rock Creek in May when we did parasampling there. I did not know that one goes subterranean. We have a section picked, if you could look at it, and I picked it on purpose because it is braided, and we want to test and see how these techniques work on braided streams also. But what we're going to do is whatever's like on Rock Creek, we'll stay on the roadside of the stream the entire time and just do it. and just, document that it is braided, but which side of the stream we're on, because I think that's important too, to test that. Does it work in all kinds of stream features? And that's why we pick such a diverse collection of streams.
Yeah, I mean, just to throw out a couple thoughts there, if you've got a braided stream, ideally, maybe you can sample above and below the braid so that you're not wasting a bunch of samples sampling all of the channels. But on the other hand, it is important to know from a detection standpoint. So I could see potentially either, depending on the extent of it, either again, trying to sample above and below the braid if it's not, too lengthy of a section. And if it is a really lengthy section, then yeah, maybe it would be good to sample multiple channels. And then back to the Rock Creek example, where it can go subterranean some years and in some places. I think it would be neat to if there is surface water, to go ahead and sample it, even if it's not floatable by ducks. I think that would be an interesting curiosity. But I think if it goes completely subterranean, I just wouldn't sample that reach.
Okay, thanks, Bryce.
Yeah, definitely. Thank you for that. Those are really important things to think about and things that I hadn't thought about yet. So I appreciate that a lot, Bryce. Thank you.
Ollie, one more question.
Yeah.
Is there a minimum water depth? I'm thinking of like late summer, and it's really shallow. Like, are you potentially looking for deeper sections with that filter?
There's not a minimum depth. No. As far as just like for the survey method, or like for like taking an eDNA sample in general,
Right.
there's not a minimum depth in like to take the sample. And that is also something that I don't think I've put a ton of thought into. I think which I'll have to think more about this, but I do think if it's like a section that's so shallow that we wouldn't really expect to see birds on, it might still be worth taking a sample because the DNA could be like flowing through that section if they're like just right above or right below. But as far as like for the protocol, you could take it in like really shallow water. Some of the examples that the genomics lab gave me were like creeks that were like as wide as my laptop and really small, and they could still take DNA on that. Cool. Any other questions? These are great.
Yeah. Holly, Gerard here. Can you hear me, Holly?
Yeah, I can hear you.
Okay. Question on the pumps. If those things go south, are we allowed to wade in that stream and gather water up above where we're standing and just hold that filter in the stream and equate to 5 liters of water?
That's a really good question that I should ask the genomics lab about.
Hey, Holly.
I know how that stuff goes. A lot of times stuff goes south with the mechanical aspect of things. And if it's allowed, I think we could do that. Just wade out into the stream and keep that filter upstream from your body.
Yeah, for sure.
Holly.
Yeah.
It's Lisa again. That's one reason we picked such a short section of Trail Creek on the Flathead, because Kaz told me that survey is done completely in stream. You're not walking the shore. So we do have to come up with some techniques to have all that equipment out in the water. So we do have to, I don't know if anyone's on this call that's familiar with Trail Creek. I've seen it once. I think that maybe you could set the equipment on a rock or something nearby, and there are logs. So maybe that's what you'd have to do, is pick a spot like that. But that creek is, people wear waders. You never get out of the creek because the shorelines are so steep.
Okay, that's good.
Good question, Gerard.
Yeah, that is. And I will inquire Gerard about like if something happens technically with the pump, what we could do.
And Lisa, I got like for carrying my pack rafts and stuff, like Malcolm had a rubberized kind of a backpack that turns into a dry bag. You could put that pump and stuff in there for like Trail Creek area or instances similar to that. And it's a backpack that you just have on your back, and then the filter hose would come out of that and allow you to gather water sample.
That's a great idea, Gerard. Thank you. You're always thinking ahead.
Does that pump need to sit flat in order to run properly?
That's another question I don't know. I will ask.
I bet you don't need that flat.
And it also might need air circulation, so it can't be in a pack. So other things to ask about, Holly.
Yeah. Thank you.
You could have it in the pack raft, just floating, and then it'd be flat, and just pull it up behind you.
Yep.
Cool. Awesome. These are all really good questions. Any other questions before we move on about eDNA?
Yeah, Holly, this is Barb. Can you hear me?
Yep, I can hear you.
Great, thanks. In the protocol, it said that we needed to keep filtering after we had a filtered clog, so that we should burn through more kits to get to 5 liters. But in your presentation just now, I thought I heard, sample until you until the clog starts, but don't keep filtering in the same area. Can you clarify?
So yeah, that is something that I am also a little bit unclear about, that I have in my notes to ask the genomics lab about. But they have something that's like filter until you have 5 liters of water or a certain amount of time has surpassed. So like if it's just going really slow, like 20 minutes or something. And then that's where on this sheet where you would record the like volume of water filtered would be like, okay, we filtered for 20 minutes, but we only filtered 3 liters of water because it got clogged. That's where you would record that. At least that's how I understand that comment. But I will clarify that for you, Barb.
Thanks.
Cool. Any other questions?
Yeah, Holly, this is Dave Kemp on the Helen Lewis and Clark.
Oh, hi, Dave. I hear you.
Quick question. Do you know when we'll probably be able to get the eDNA kits? Because I'm going to have to haul in our stuff with stock because it's a backcountry survey for the location. So if we can just have that planned accordingly, because sometimes during certain times of the season, even though we have 60 head on the district, a lot of them are get called for with our backcountry trail crews. So the sooner I know when I'm going to be able to get those, I can plan to get it hauled in and dropped off at a staging point.
Yeah. Yes, Dave, we should talk about this just like outside of this meeting, because so all of the eDNA kits are being sent to me, and so I can distribute them. I like thought that was going to be like logistically easier than having the genomics lab send like different numbers, different places. But I can let's chat and figure out like when you need the kits by, and I will make sure that we can get them to you. And we'll get that on the schedule.
Okay, sounds good. Appreciate it.
Cool. Yeah, no problem. Other questions? Okay, cool. I'm going to move on.
Oh, sorry to interrupt, Holly. Barb, did you get all your questions that were in the chat answered?
Oh.
My other question is, do you want us to ID other species other than harlequins on these surveys? I feel like I'm going to be busy enough with 6 miles of river.
Yes, we do want you to record other species, although you don't. I'm going to back up to this. Although with this is a really great question. Thank you, Barb. So with the ground-based forms, we do want other species, but you don't need to record like behavior information. So like awareness, etho, people like distance away. But we would like to know if you see like other species and how many and kind of like where they are, but you can just record more like just minimal information about the other species of birds that you see.
Okay. And
Yeah, we're only Barb, sorry, we're only interested in like other water birds, like the dippers, American dippers, spotted sandpiper, any waterfowl, mallards. If people can identify to that level, and if they can't, that's fine. Just let it go.
just send us the list of the abbreviations again. That would help. I never remember those. Thanks.
Yeah, we'll do.
Okay, 4-letter acronyms.
Yeah.
Cool. Okay. Cool. Any other questions? Okay. Move on now to talking about game cameras. So the game cameras we're going to place 2 cameras every river mile, and all the survey lengths are between like 2.5 to 5 miles, and we're going to be testing 2 different settings of cameras. So one camera is going to be on a time lapse, taking photos every 5 minutes, and one camera is going to be on a motion trigger. And the reason why we're doing this is because oftentimes cameras are used not on water and also not on waterfowl. And so we're just curious if like a time lapse or a motion trigger, maybe like it'll just get triggered by the water and just this SD card will fill up in, a day, and that's not very helpful, or if we can still capture birds using a time lapse where we just take a photo every 5 minutes, knowing what we know about their behavior and how they tend to stay within a mile stretch and forage within a mile and then move back upstream and then forage down in that same mile stretch. And so we're doing 2 cameras, although some cameras can have both like motion trigger and time lapse in one camera. The reason why we're going to put 2 cameras is, like I said, if that motion trigger just like fills up within a day, the time lapse SD cards doesn't get filled up and doesn't like that cameras can still be used. And so for each camera, we're going to place one every river mile, but you will have a 300-meter buffer on both sides of the camera in which you can place those cameras. So if at that like 1 mile mark, you're like, this is a bad spot, like maybe it's just like a roaring rapid, or there's like a canyon and you don't have anywhere that you could put your camera, that's okay. You have 300 meters on either side that you can like find a good spot to put the 2 cameras. And ideally the cameras are placed side by side where you put them. So the camera settings, so cameras are coming from like many different places. I have some cameras from the Millspa lab at UM. FWP has some cameras, different Forest Service districts have cameras. And so potentially folks will have different like models of cameras. And so the most important thing for me is that the settings are the same. So, and if you don't know how to like work one of like whatever model camera you have, let me know. I'd be happy to like look up a manual and help talk through what we want. But this slide right here is more or less the settings we want. So yeah, this date and time. And then, like I said, one will be on time lapse and one will be on motion trigger. So if you're also using different brand of or model of cameras, make sure that they have these options. Some of the options that I've looked at, you have for the time lapse, you actually have to trigger or cover the motion sensor so that it, like with a piece of tape or something, so that it won't also be triggered. For photo quality, we're just going to put it on like medium, so that way it can take, it's not like poor quality, but also it's not going to take up as much space as like a high quality photo. For the photo delay, for the motion trigger, we want it at 10 seconds. And then for both the time lapse and the motion trigger, we want 3 photos to be taken each time, temperature to be in Fahrenheit. And then, so naming the camera is going to be really important. So how we want each camera named is the stream code, which I will make sure you have before you go out, the river mile you're on, and then either TL for time lapse or MT for motion trigger. So I have an example here, like UMC1 TL, which would stand for Upper McDonald Creek River Mile 1 time lapse. And so then the other one on River Mile 1 would be UMC1 MT for Upper McDonald Creek River Mile 1 motion trigger. And then for detection distance, just whatever is normal, or like on the examples that I had were about 60 feet. And then for trigger speed, we want it on fast, because if they're flying by or moving quickly, we want to make sure that we capture them. And then for the time lapse frequency, we're going to put that to 5 minutes throughout the day. And then camera placement. So for camera placement, I haven't thought about, well, here in Glacier at least, we're not going to be using like stakes to put stakes in the ground because of like wilderness and permitting. And so we're going to try and use just natural features. And if folks on all the creeks could do that, that would probably be ideal. I'm not totally sure how like wilderness values work in like some of the other creeks, if they're like in wilderness or not. But we're going to be trying to secure these cameras to features like trees, logs, stumps, rocks, placing the camera side by side when possible. And then also when you're placing that camera, you do have that 300-meter buffer. So just thinking about like, where would you most likely be able to capture these ducks, like on slower backwaters, across the main channel, on some still pools where they're foraging, where you've seen them resting, and trying to place the cameras strategically in that zone that I have for you. And then I do have a camera placement, so like camera name, so date, observer, survey creek, camera name, the river mile, motion trigger, time lapse, where it is, what time you placed it, and then what is the key. So every camera should have a lock and should be locked. And so if it has like a different key code, just make sure you record that. So when we go back to retrieve them, we know which keys to have with them. And then a general description. So we know, like, are we looking at, a log jam or a root ball or anything like that. But that's kind of the gist for cameras. Do we have any questions about cameras and camera placement?
Ollie, I do.
Yeah.
Are we allowed to have zip ties? Because I know fastening some of those cameras with just a strap is kind of a nightmare.
Yeah, I think that's okay. Just making sure that, you're not dropping them in the water, and just being really aware of your, just trace. I think that would be okay. Cool. Okay. I'm going to move.
One
Other question?
more question. Sorry.
Yeah.
It's Christina. I would just say, putting these cameras up is hard. It takes a lot of finesse. So I would just encourage people to play around, unless you're already really familiar with putting cameras out. Play around before you head into the backcountry. Yeah, because it's hard.
Yeah. Yeah, I agree. Thanks, Christina. And for folks that are near me and Glacier, we have our cameras here. So if you ever want to come and just like have a day, we can play with those cameras and practice putting them up as well. And one thing I would recommend too is a lot of the settings on the cameras you can set before you go out and they won't change. So that will save you time in the field of like naming the camera and whatnot. Just like get those settings in place before you go out. Cool. So this is just a couple of slides of the. Oh yeah.
There are a few other questions in the chat box. Can you see the chat? Do you want me to read them?
Yeah, I can't see it with this, so that would be
One
great.
of them was any thoughts on trigger sensitivity for consistency? I've noticed some game camera models have sensitivity settings and some do not.
Yeah, that is a good question. The model that I have doesn't have that, and so I overlooked that. I don't know if Hannah, do you or Christina, folks who have worked with them, if you guys have thoughts about that?
I need to look back at the cameras that we have and remember what we do.
Okay, I will write
we can
that
circle
down.
back and find that answer.
Cool. Yeah, I will write that down and we will get that back to you.
And then two other questions that were in the chat. One was about getting forms, data sheets digitally in advance so people can print them onto waterproof paper.
Yes.
And sorry, go ahead.
Oh, no, go ahead.
And the other was just a note that on this form, the camera placement form, you have longitude and latitude with UTM east and north.
Yes. Swapped. Oh, yes, I see that now. Thank you. Okay. Sorry about that. There was a lot of many tired days making this protocol. So thank you for that that catch. And yes, I will make sure that folks have these forms prior to going out in digital copies, so you can print them out and however you like, whatever paper you want. And so I'll make sure that that is accessible for everybody. Cool. Yeah, thanks for reading the chat box. I can't see it with the PowerPoint pulled up, so. Cool, so this is just a schedule. I put it all the different, so each forest is a different color on here, just so folks can see like when different surveys are being done, and you can see sort of like end of July, that week of July 25th is when things really pick up, where we have overlapping surveys, and then in August there's a lot. So everything's happening all at once, and this project literally could not happen without each and every one of you. So I'm very grateful, and I'm excited to see what we learn. And yeah, so this is what a schedule looks like. The other things I want to talk about, so gear, this gear list is in the protocol that I sent, and I will probably make a few edits on just some things that I've caught like later in the protocol after sending it out, like some edits, and send this out. But with this gear list, what is underlined are things that I will be getting to you. So I'll be making sure to get you data sheets and pencils, and then the streamflow kits. And then the cameras have a hyphen just because like some of the cameras might be coming from me, might be coming from FWP or your own forest district. So they're kind of coming from all over, but just making sure that those are things that people have. And then the eDNA, the kits are being put together by the genomics lab. And I will make sure that each creek has the appropriate number of eDNA sample kits and plus some extras just in case prior to going out. And so this is the gear list. And then the other things that I am going to be providing for folks is maps of each creek. I'm working on these at the moment. So each creek I'm making 3 files for that can be downloaded onto like a mapping program like Gaia or Venza, Caltopo, or even a GPS that will help. So there'll be a geo-reference PDF that has the creek and then the river miles with the buffer, so people know where they are. You can put this is super helpful if you like to use the mapping software Avenza, you can bring this into Avenza, and then it will show you on this map because it is georeferenced. So if you're in this plane, you'll be like a little dot on there. And then if you don't use Avenza, I'm also creating 2 different KMZ files that have the river miles and the buffer as well. And these files can be used in like Gaia or Caltopo, or on, you can download these files onto like a GPS, like a physical GPS unit if you prefer to use that. And so I'm still working on these, but I will make sure that people have them for their creeks before that they go out, and so that they can have them downloaded onto their device. And these should be helpful so you'll know if you're within that buffer and when you can start looking for a camera placement. Cool, so that's the end of my presentation. Are there questions that I can answer for folks?
Hi, Holly. I was curious about how many pumps you might expect out of one of the batteries. We were getting about 5 to 6 in Wyoming this year.
Okay, that is something that's on my list to ask the genomics lab, actually. So I will make sure to get that. That's good to know that you were only getting 5 to 6 in Wyoming.
What was the question, Holly?
How many pumps that we can get out of one of the batteries?
And someone said only 5 or 6?
Yeah.
Correct.
Oh, yeah, then we need to have more than one battery.
Yeah. Yeah, that has been on my list of things to ask the genomics lab, so I'll make sure to. Thank you. Oh, Gerard, I think you're muted if you're asking a question.
Can you guarantee that we keep our packs under 100 pounds?
I'm gonna try my best.
Depends on how many batteries we have to carry.
Yeah, it's true. Might just go out and place one every mile, like before you go out.
You're awesome. Nice presentation. Thank you.
Yeah.
Cool. Yeah, awesome job, Holly. And thanks everyone for the questions, because it really gives us some things to look at, fine tuning and figure out some answers. So I really appreciate everybody participating.
Yes, me as well. Thank you everyone for all your great questions, because there's like so many things, and like I said, this project literally can't happen without all of you. So all the different minds thinking of questions is really helpful for me.
It couldn't happen without you.
That's true too.
Yeah, I'll just put out there why we have this big group. You know, Montana and Wyoming and Idaho and BC are hoping to do more of a range-wide effort across the next few years. And we thought we were going to have to test all these methods, and we weren't sure what to do. And then Holly came along, and she is doing so much of that work for us. So we're just super thankful for this graduate project.
Cool. Well,
one more request. Holly and Lisa and Allison, could you guys stay on for a couple of minutes after this?
Yes, we can do that.
Definitely.
Great.
Jake, do you have a question?
I don't. I just
Okay.
figured I'd show up at the end for the last hurrah.
Okay.
Awesome.
Good to see you.
If we don't have any more questions, I guess we'll call it. It's our 20 minutes. So thank you everybody for your time and for being here and for being part of this.
Thank you, Holly.
I'll see you soon. And
Thanks everyone.
Thank you.
Thanks, Holly.
Thank you.
For the presentation.